All right, geometry, Unit 6, Lesson 10. Yes, we're still in geometry, not algebra. Parallel lines in the plane. So let's practice some things. Translating lines, warm up. Student task statement says, draw any non-vertical line in the plane. Draw two possible translations of the line. Find the slope of your original line and the slopes of the originals. Okay, I'm going to make this a little bit bigger. So I'm going to draw a line. Terrible at drawing straight lines. It's so hard on this digital whiteboard. So I drew a non-vertical line in the plane. Two possible translations. Let's just do a translation. Just sliding it. I slid it approximately a little more than 2. Okay, I could actually figure out how far I slid it. Not by that way. Oh goodness. So that was my slide. Okay, that's 2 possible translations. Anything else? I mean, I could go a little bit further, right? Find the slope of your original line, the slopes of the images. The slope of this one is, I did a 1/1, so a rise of 1, a run of -1. I should write that in black since that's my, I went up 1 and left 1, so a slope of -1. The red one is also a slope of -1, and the blue one is also a slope of -1. Just doing rise over run, right? Okay, check. Did all of those. Let's see what's next. All right, let's look at Priya's proof. Consider any two parallel lines. Assume they are not horizontal or vertical. Therefore, they must pass through the xy axis. They must pass through the x-axis as well as the y-axis. This forms two right triangles with a second congruent angle. Call the angle theta. The tangent of theta is equal for both triangles. Therefore, the lines have the same slope. So let's mark a few things here. I know that that's a right angle and that's a right angle, correct? They've talked about this being theta and that being theta. And we know that the tangent of theta is opposite over adjacent. So we're going to say A over B. The tangent of theta is C over D. So I'm just make a note. Tangent of theta for orange triangle is A over B. Tangent of theta for blue triangle is C over D. Not sure what to do with that yet, but it's there. We do know that tan theta and tan theta are the same. Okay, we've already said that the two angles are equal. So tan theta and tan theta are the same, so we can say A over B equals C over D, right? Those two things are equal because the angles are exactly the same. So A is a rise, because that's an up and down, and B is a run, because that's left and right. So the slope of orange triangle's line is rise over run, A over B. So that's the slope of the orange one. C and D is rise over run. Okay, rise over run. So that is the slope of the blue triangle, and they're equal. Okay. I can also say that if I have those two lines, that's beautiful, isn't it? Those two lines, the x-axis is the transversal. So we know that there's theta and there's theta because we made the triangle, right? We've got the two triangles there. It's a bad drawing. I've got the blue triangle and the orange triangle. I do know when, let's see, if that's a transversal, those are opposite interior. We learned a long time ago that when opposite interior angles are congruent, lines are parallel, which means slopes are equal, right? What else do we know? I think that's it. Okay, that was question number 1. How does Priya know the right triangles have a second congruent angle? When those are equal, we know that, we'll call that beta is equal. So question number 1, because thetas are equal, we also know betas are equal. Because when two angles of a triangle are equal, the third is equal to. And I'm sorry, I'm really out of order. Up here, I answered question 2, which said show or explain what it means that the tangent of theta is equal for both triangles. I did that in the wrong order. And then how does this prove the slopes of the parallel lines are equal? That was number 3. Great job, Miss Carly. Totally out of order. Crazy. All right, thank you, Priya, for that awesome proof. All right, 3, prove your parallelogram. Our question here, write the equation of a line parallel to y equals 2x plus 3 passing through point -4, 1. So that number 1, we learned y minus y1 equals mx minus x1 in the last lesson. Here, I know the slope is 2. So my equation can be y minus 1 equals 2 times x plus 4 using this equation. Not too bad, right? We've already learned some of these things, so we're just going to go back and grab them and use them again. Number 2, graph both lines described in the previous question. We're going to do our best. The first one has a y-intercept of 3 and a slope of 2 over 1. So I go to the y-intercept of 3 and I go rise of 2 over 1. Rise of 2 over 1. And I graph it the best I can. Okay, the other line has a slope of 2, but we know what point it is. So I'm going to graph that point of -4, +1, and a slope of 2. So up 2 over 1, up 2 over 1. If we were on graph paper, these would look perfectly parallel. Okay, those lines will never cross. Trust me, I drew them. Draw a parallelogram using the 2 lines you graphed, using -4, 1 as one of the vertices. So now I need to draw, this was -4, 1. Doesn't matter where the other one is. I need to draw 2 more lines that are parallel to each other. Remember, that's how we mark parallel. It's a parallelogram. It's not a rectangle or a square, so I just know it's a parallelogram. What is the slope of this new line? So the slope, we're going to call it the new slope. Okay, we're not sure what that new slope is. It could actually be anything. It just has to be a negative slope. So we can make it a slope of -2, and it has to go through point -4, 1. So I'm going to say y minus 1, -2, x plus 4. So if I'm right here, I'm going to go a rise of 2 and a run of -1, a rise of 2 and a run of -1. So my gray line isn't quite right, but that's okay. And now I need a parallel line. Let's make it a parallel line through this point. That point is 0, 3. So y minus 3, -2, x. I'm going to go a rise of 2, a run of -1. So it doesn't matter what those lines are as long as they have the same slope to each other. Okay, these slopes need to be the same, just like these slopes need to be the same. All right, that's a parallelogram. Prove that your figure is a parallelogram. Well, I know they are because my slopes are equal. The slopes of the red and blue lines are equal to each other, and the slopes of the two green lines are equal to each other. And we can also say, which is really cool, and I'm out of colors. Let me see if I can get, nope, I'm out of colors. Bummer. I'm just going to use yellow. I know that the green lines, and if this is a transversal, then that angle and that angle are equal to each other, therefore they're parallel. Or if I have, let's get rid of all those, these two lines, and this is a transversal, I know that this angle and this angle are equal to each other because they're parallel. And that's really all we need to do to prove that it's a parallelogram. That's pretty cool. That was it. All right, easier lesson. I'm glad. Please reach out if you have any questions at all. Okay, I'm happy to help at any point.